In this video, I will show you some techniques for verification and experimentation on the output analysis. Now let's start with the verification. As I mentioned in the lecture, one of the way to verify your model if it is built exactly as it is described in the conceptual modeling stage. You need to read through all the information of the model with your team. And that technique we call walkthrough. But we also can do something else beyond that. Now, let's check if the processing time of the server is correctly described by conceptual modeling stage. You can check the processing time for the main 2, for the self-checkout 1, for the self-checkout 2. Because of the time constraint, in this video, I will show you only the processing time for the till. You double click on the till, and you see in the conceptual modeling, you described the service time at this till follows a triangular distribution with low about 2 minutes, up about 7 minutes, and most likely values is 5 minutes, right? We need to find some way to verify this type of information. And to do that, we will use some very basic visual logic coding. So basically, we need to capture the time when the work item about to move into the till and the time when the work item about to leave the till and take the difference between these two time measures. We will get the processing time for the till, right? And to do that, we need to create two new variables or two labels. One to capture the time when the work item move into the till, and another label to capture the time when the work item about to leave the till and take the difference between these two measures. You will get the processing time for the till. So first, we will create two labels. Go to data and roost, go to labels, and we can add new labels. Let's call the first one till start processing. And another one is till stop processing. And click OK. Now we already have two labels. We want to set the value for these labels by using visual logic coding. You can double click on the till, go to routine in, go to options, and choose after loading the work item. Right here, you can search for the function called set. Double click on it, and a new dialog will show up. You need to provide some information for this visual logic code. In particular, we would like to set the label till start processing equal to the current time when the work item move into the till, right? You can choose label and double click on till start processing and click OK right here. Right here, basically, we just tell the computer, please record the time when the work item move into the till. That's it. And we can do that by choose other label data and choose simulation time and click OK. And you can close this one, right? So right here you see this code is thread. It means that the code is available to execute when we run the model again. Right. Remember, we still need to capture the time when the work item about to leave the till. So we need to have some adjustment with the routing out decision. We go to routing out and we choose more. And right here, we choose on work complete, right? And the same, search for the set function, double click on it. And right here, we want to tell the computers use the label to stop processing and tell the computer record the time when the work is completed or the work item about to leave the till. We choose the three dots here, go to other level data and choose simulation time. Right, and click OK. So we already tell the computer to record two important time measures to compute the two processing. Try to make sure that you already save the output file properly. We can have a check. You can double click on the endpoint here. So in the current model, we have two endpoint, right? So if you want to check the two processing time, you need to save the output for this endpoint. But in case you want to check the processing time for each self-checkout machine, you need to check the output in this endpoint. All right. Now we choose file. All right. And try here. Let's call as till and new and save it as CSV. Right. And click OK. Don't forget to run the model one more time. Good. So you see we have the two last columns are the two time measures we just recorded using the two new labels. One is till start processing and another one is till stop processing, right? Very good. All right, so we are ready to compute the processing time of the till. Let's call it till processing time, right? And basically, the till processing time equals to the difference between the till stop processing time and the till start processing time. Good. Right. All right. So based on this new data, this new column, we can create a histogram chart. We go to insert and you can go to recommended charts and choose the histogram and click OK. All right. Very good. So right here, I say till processing time. Now you already see the shape of this distribution, right? You need to justify against what you specify in the model. Remember, in the model, we specify the service time at the till follow triangular distribution with 257 parameters. Okay, you need to use your statistical knowledge to justify if it makes sense for the two processing time. So this is one way to verify. If you go to help file, the browser will open the search bar for you to search any information, any resources from Simulate commonly. So right here, I will type distribution and I search for distribution. So you see, we have a lot of information about distribution. You might want to restate and justify where the distribution is correctly described as in the conceptual modeling stage. Great. Another way to verify the model is using animation inspection. So basically, we run the simulation slowly so we can observe the route the work item takes, right? So let's run the model, but very slowly, like this one. Now the model run very slowly, so you can see where the work item is going to. And this is very useful for you verified the model that you built, right? Or you even can use the step, right? You can click on this one, step by step. Good. And even we can make the animation a little bit better. We can change the graphic icons of the objects in the simulation structure. For instance, I can change the graphic of customer arrival. Double click on the object, choose graphics, and right here you should click on the current image and go to the library. So in the library, you have a huge collection of the object image, and you even can select an external image from the internet and make it as a new icon for the object. Okay, so I just choose the first one, right? And you can change the image for the rest of the object to make it look more visual, to make it easier for the inspection. All right, now let's discuss a new concept called multi-replication. Remember, because we introduced probability distribution for different objects in our simulation, for instance, we have the average distribution for customer arrival, right? We have the triangular distribution for the two, and we have another average distribution for self-checkout 1 and self-checkout 2. So basically, we already produced the randomness in our simulations. And because of that, we will have some variance that is associated with our simulation output measures. And to improve the accuracy of our measures and make our simulation is more comparable, we may want to run multiple replications. We use multiple replication because although we can obtain result from a single run of simulation, say for 1 day of operation, that will only provide measures based on a specific stream of random numbers generated by the simulation software. And the random number stream used to generate values for the theoretical distributions. For instance, those we already added to customer arrival to the two to self-checkout 1 and to self-checkout 2. Each time we run the simulation, we produce a single sample of results of simulations. And we can generate multiple samples by running the model multiple times. And each time we change the random number stream. If you go to advanced, go to random sampling, you see the current random stream set number is 1. And with this random stream set number, the output for the till is 111 customer. And the output for the self-checkout machine is 130 customer. Now let's try the random stream set number a little bit. So let's say 2, and let's run the model one more time. See, the result slightly changed. So now the output for the till is 113, and the output for the surgical machines is 132. All right. And of course, you can manually change the random stream set numbers by yourself, like several times to run the multiple replication. Okay. But the software is good in the sense that we don't need to do it manually. We can ask the software to run the simulations in 50 times and produce a range of the output measure. Okay, and to do that, you can go to Home and choose Run Trial right here. You can run the trial setup and you can specify 50 runs. And that's it. You can run the trial, right? Very good. So now in this window, it shows you one type of KPI. That is the average time the customers stay in the system. And it's produced you a confident interval 95% plot, which we call more plot, right? After running 50 times, the computer produced a range for this type of KPI, the average time in the system, right? So it means that most of the time, the computer can produce the output around this measure, but very unlikely, just several time of running simulation, the computer will produce quite extreme values like 8.28 minutes or 13.85 minutes. Most of the time, the computer will produce the average value of 9.98 minutes. And this is a grounded output measure. And we can believe that most likely the customer will stay in our system around 9.98 minutes. And of course, you can choose more KPIs for your result. You can click Add here and choose any object that you want to see a range of value for that object. For instance, I want to choose the till right here, and I choose Add all results related to the till. Okay, and then I run the trial one more time. Good. Right here, you see the computer produce some important measure for the till. For instance, how much time the till is available without customer and the staff just keep waiting for the next customer, and how much time the till is working completely, right? And instead of single value for the output, the computer produce the more plots. So it is your responsibility to justify the range of each KPI. And it is also brilliant to choose relevant KPI for your projects.